To simplify this radical, I like to split it up. You can split up radicals as long as they're multiplied together, as long as there's no adding or subtracting. And then there's a couple different ways to think about this. I look at this, square root of 16 is 4, so that's 4. Square root of y to the 6th. Okay, so it's saying what times itself makes y to the 6th? Well, it's y to the 3rd, because if you have y to the 3rd times itself, you get y to the 6th. So the square root of y to the 6th is y to the 3rd. So your answer is 4 y to the 3rd. Another way to think about that, if you have the square root, that's really the same thing as the 1/2 power. So if you have y to the 6th to the 1/2, and then you use the fact that you can multiply exponents, 6 times 1/2, you get y to the 3rd. So that's another way to come up with y to the 3rd there. 25. X to the 3rd times x to the 4th. Well, I know that the rule is when I multiply like bases, I can add exponents. So that's x to the 7th. Although I could just kind of write this out too. X to the 3rd times x to the 4th is x to the 7th. Okay, I'm going to start here within the parentheses, x to the 9th over x to the 4th. 4 of the x's will cancel with 4 of the x's here, leaving me within the parentheses x to the 5th power. Otherwise, I could use the fact that I know that when I divide like bases, I subtract exponents. 9 minus 4 is 5. So now I have x to the 5th squared. And if I have an exponent raised to another exponent, I can multiply exponents. So this becomes x to the 10th. Changing forms to exponential form, this number right here becomes the numerator, and this number right here becomes the denominator. So this is x to the 4/5 power. Simplifying the 3rd root of these. Again, kind of like up here, you can either think of it as what times itself makes x to the 6th. X squared does, because x squared will be x to the 6th. And what times itself 3 times makes y to the 12th? Well, y to the 4th. Another way to think about that is to change this from radical form to exponent form, and that would give us x to the 6th, y to the 12th to the 1/3 power. And then you could multiply your exponents here. 6 times 1/3 is 2, so that'd be x squared. And 12 times 1/3 is 4, so that'd be y to the 4th. X squared y to the 4th. You can't subtract or add radicals unless they have, I call it like terms, unless they have the same thing under the radical. So at first glance, I would say, oh, you can't do anything with this one. But root 12 can be split up and simplified. I can split it up into root 4, root 3. And then I know that root 4 is actually 2. So this is 2 root 3. Root 12 is really 2 root 3. So now I have the same ending. 2 root 3 minus 1 root 3 gives me 1 root 3. Almost like 2x minus x. 2 root 3 minus root 3 equals root 3. I'm going to skip ahead to this one because this is kind of similar. I have the same thing under the radical here. It's almost like having like terms. So I have 2 root 5 plus 8 root 5. 2 of them plus 8 of them makes 10 of them. 10 root 5. This one here is a little trickier. You need to multiply both top and bottom by the conjugate of the denominator. We want to get that square root sign out of the denominator. Remember, to make a conjugate, you just do the same, that should be a 4. You just do the same thing except you change the sign. I have to multiply by the same thing both top and bottom because that's what allows me to multiply I'm really multiplying by a funny form of 1, so I'm not changing the value of this expression. Okay, now we just have to do our distributing. That's 3 root 3 plus 12 root 3 times root 3 is root 9, or 3, regular 3. And then this, I'm not even going to write down because it's going to cancel out. Plus 4 root 3 minus 4 root 3 adds up to be 0. And then minus 16. So I have 3 root 3 plus 12 over negative 13. And that's my answer. That is simplified, more simple than this, because the square root is out of the denominator. You can't have a square root in the denominator.